Hello, hello. Just want to do a quick sound check if anyone is live. I want to see you guys live on our Facebook. I'm streaming here from my office. Very happy to see you here. Just want to check with you guys if you can hear me. Tap in a 1 to the chat box if you can hear me. I'm going to check with my another device whether you guys can see. And I would wish to actually communicate with you on Facebook Live as well. So I'll be having my Facebook device so that I could actually see responses. And if let's say you have any questions at any moment of time, you could definitely write down or just type it into the comments. All right. So we're going to start in, say, 1 more minute, right? We're going to do it sharp on the dot. Right. Okay. Yeah. Before that, let me just check if anyone is tuning in. And if you're tuning in from different countries, if you're from Malaysia, please give me a happy face. All right. If you're tuning in from Malaysia, please give me a happy face. If you're tuning in from Singapore and the other countries, give me a heart, okay? A heart. All right. So for those people that are tuning in from, let me see. Yay. All right. Okay. Good afternoon, Kelvin. I can see you guys here. Thank you very much for tuning in today. And today I'm going to share you a little bit of secrets from what my industry comes in from. Before I start, I would like to also introduce a little bit about, oh, I see hearts. Okay, so I know that somebody is coming out of Malaysia. I am going to share with you the topic about how and the secrets about how we calculate our plastic cost. Okay, this is the biggest question, right? Like many people who is in the industry who actually wanted some of our service will want to know how we calculate our cost. All right, how are we going to get the price that we get? And somehow or other, if you ask other people, some other people give you other kind of pricing, right? Then you will wonder what is the difference and how can you make a decision. So I would like to prep you guys up, irregardless of which industry you're from. You may be from the supply chain industry, you may be an engineer or a designer that was trying to design some parts for your products. I would like to give you some insights of how we calculate our costs and we charge it to you. The reason why I want to do this is because I experience a lot of customers, our customers, who actually came to us and say, hey, how come some other people charge us this kind of price? And at the end of the day, we have to tell them, all right, so there are different variances in terms of pricing. And in terms of the pricing, you get different type of output, right? And there's so much different kind of price that can vary, all right? So without further ado, and this particular sharing session, I intended to do it in a very in-depth kind of manner. So at the end of the day, I'm going to give you some homework as well. And remember a very small little bonus that I'm going to throw it out to you guys. A small little bonus is going to be at the end of the session, which I'm going to share it to you. The reason why is because I knew that a lot of customers is looking for this particular bonus, and I knew that this particular bonus is going to help you guys a lot in terms of understanding how this material comes in, right? Typical questions that they always ask me is like, what is the cavities should I have when I develop a mold? How much should I develop, or how much is the right investment for a mold? So this is going to tell you how much is the difference, okay? This particular sharing, we are not going to touch on, amortization, because amortization has another sharing that I'm going to plan it out for you guys, because amortization is a little bit different because we have to calculate how much is the mold cost, and then how do we put the amortization back into the part cost, right? Amortization means if let's say you are a designer and you have interest to develop a product, and this particular product you sort of don't want to put in a big chunk of investment, and you would like to put this investment into the part. With a careful exercise of this, you could negotiate with your suppliers that you want not to put up and upfront for the mold. And you could actually impart some of the cost into each and every part so that it's less burden of you. However, this is actually very dependable on the market demand. So this time around, we're not going to cover that. This time around, we're going to be purely discussing about the costing. When you ask a supplier to create a part, right, why are they charging you this price, right? So allow me to share my screen. Yep. Allow me to share my screen where you're going to, oh yeah, okay. Before that, after so much of talking, you may want to know who am I. So my name is Samantha. I'm the Managing Director of Glasfil Polymers Sdn Bhd. We're a proud company that produce plastic consciously with the tagline of Sustainable Polymer Designer, because we basically design in the end in mind of all the products that we produce. We want it to be conscious and also be very environmental friendly. That doesn't mean that we use environmental friendly material, but we want to make sure that the products that are produced by Glasfil, we sort of know where it went. I am a big fan of like tracing the end life of what I produce. I would want to roughly know where it's used or how are you going to put in a recycling concept to the products. So if let's say you're a fanatic about like designing conscious products or designing sustainable products, do get in touch with me. I'll be very delighted to talk to you about building environmental friendly products in plastics. All right, so but today our topic is still about plastic injection molding cost calculation secrets, okay? And it's specifically for those people that are in purchasing departments or probably those people that are in supply chain management. You may want to think about today you're moving your mold from one country to another country, or you're trying to actually source for new suppliers for cost down. I roughly share to you how cost is being calculated in plastic. So basically today we are going to cover a little bit about like plastic 101. What is a plastic? What came up from? How do we come up from? Things that we're not covered today is we're not going to cover about blow molding. Blow molding means bottle, where you have a shape of a bottle. Yeah, we're not going to cover that. We're going to solely cover about plastic injection molding. We're not going to cover plastic packaging because that's not my core as well. So we're going to cover solely on plastic injection molding. Okay, so those people who are staying tuned, just give me a 2, type me a 2 inside the chat so that I know that you guys are still alive, right? So you guys are still around, right? Okay, so a little bit about myself. We're not going to cover a lot because at the end of the day, I'm going to make it very simple for you guys to understand and also very easy for you to sort of work it out, right? Because importantly, you need to understand the concept, okay? So basically, Glasfil Polymer is born since 1992. I'm the 2nd generation owner. So our vision is to be a role model in circular economy sustainability in plastic industry. So talk to us if you are really, really interested in creating sustainable and conscious product. Okay, so I mentioned about the secrets, right? We actually have a lot of secrets in the plastic industry because somehow you tell a lot of people about plastics, they seems not to be able to tell you how we calculate our cost. So before that, just let me inform you how and what is a plastic runner. Okay, so many people will say, hey, I would like to develop things. There will be a few things that you commonly hear. These are the terms, okay? You will hear about cold runner mold. Okay, cold runner mold means this particular plastic part that comes out from the machine has this long run of material, which is not your part, okay? If you look at this particular product, you notice that which part is the part? Which part is the part? This is the part, right? This is 1, right? And this is like 2. Some people will wonder, hey, how do I get my wall plug? Okay, so basically your wall plug is being injected using plastic injection molding, and it is developed in this manner, right? And very simply, if you put it simply, this is 1 wall plug, this is 2 wall plug, this is 3 wall plug, this is 4 wall plug. And you notice that, hey, what is this then? What is this portion, right? What is this thing? This is what we call the runner. What is the function of the runner? The runner is for all the materials to be able to go through it, and after that nicely part to all the parts that's supposed to be created. So in this one particular mold, let me ask you a question. How many cavities are there? Okay, how many cavities are there? All right, those that are online, just help me type in the answer. How many cavities are there? Cavities means how many parts did you get out of this mold? Can you let me know? So we can do an exercise very simply. 1, 2, 3, 4, 5, 6. Right, so there's 6 cavities in one set. Okay, typically we will do it very evenly and symmetrically. So you have set number 1, set number 2, and then you have set number 3, and then set number 4. So this particular mold, if let's say people were to ask you, or any suppliers were to ask you, you will need to tell them, okay, I have a mold, and this mold has 6 times 4 cavity, right? This mold has 6 times 4 cavity, which is 24 cavities, okay? And when they ask you, oh, okay, you have a mold of 24 cavities, may I know the cycle time? Okay, cycle time means here, let me just give you an insight of what cycle time looks like, okay? This is exactly like how this thing is. When the mold opens and it closes back, it closes back, right? At this moment of time, it closes back, it starts to inject, and you will hear some sound like that. So that material actually went in and formed it until once it's cool, it can be safely opened, it will open. So usually, typically, a plastic injection molding cycle time ranges around, I don't know, for this part, probably a 30 to 35 seconds. What does that mean? That means in a 35 seconds, 24 wall plugs will drop. Okay, literally a second and a half is one wall plug. Okay, this is the concept about plastic injection molding. Okay, let me see whether anyone answered it correctly. Did anyone get 24? 24 cavities? Okay, so this particular mold has 24. So if you see, are we going to calculate this runner weight and this weight? So they will ask you, what is the weight of the plastic? So the weight of the plastic is actually inclusive of the part weight together with the runner weight. And we usually tell people to separate it because so that people know that there is a runner, right? And in some situation, there is no runner, okay? I'm going to share to you why in some situation, there's no runner, okay? So typically, we're concerned about the part weight, and we're sort of wanting to know what is the runner weight if let's say you want us to give us a very, very precise quote, a quotation basically, right? So we would like to know what is the runner weight. If let's say you don't really give us a runner weight, we will make an estimation anyway. Okay, so if you can see here, I have this particular mold that was really running, full automation, no man, unmanned. So it has 24 cavities, if not mistaken. Yeah, it has 24 cavities. So this is typically how a plastic injection molding looks like. All right. So moving up next, right? This is another quiz. Let me ask you, how many cavities is this particular mold? Can we do this exercise together? I am going to move this up. All right. I'm going to use white. Okay. Let's do this together. So I knew that it sort of looks symmetrical. So I know there's a group of 4 and there's another group of 4. So this is one group of 4. 1, 2, 3, 4. So it's 16. And then it has another 4 group, right? So it's 16 times 4 altogether. So altogether, this particular mold has, anyone guess the answer? This particular mold has 64 cavities. All right. So if let's say this cycle time range around 60 seconds, like literally also around 1 second, it will get a part. Notice here, there was no part. Okay. This is pure runner. Okay. The part probably dangles below here, which we do not know what is the part of. I just capture it from internet, but this is how we calculate a cavity. So this runner, you may have another question, right? This runner, are we going to keep it or are we going to throw it? Okay, so there comes another questions. This is a runner. How much regrind runner is accepted? Sometimes coming to the most details, people will ask how much is the runner going to, how much do you put it back? Typically, I would say if the company allows it, because some mold, they do not accept regrinds, okay? Some mold, they do not accept regrinds. So some molds, they will not be able to let you put in the regrinds. Typically, a good range is around 10%. A good range. Well, we practice around 10% because if we put more, we will run into more rejects. And when we run into more rejects, actually a lot of people will think it's good because you save more in terms of the manufacturer point of view. However, to tell you the truth, it doesn't, because you will have more rejects and it comes to a point where your manpower cost is higher than the production cost, right? So we always want to carefully exercise how much we grind if it's allowed into our production. Okay, so those people that are tuning in, I really hope that you guys know what is, you guys have a clear picture, all right? So now I'm gonna share a little bit about something that is a little more different. This is called a family mold. A family mold means it has family, so it has brothers and sisters, okay? So meaning to say in one mold, you actually have maybe a combination of different parts, which is possible, right? Because on molds that are low runs means probably your runs, it's like 1,000 or 2,000, and you do not want to develop individual molds, you can actually do a family mold. However, when you talk about family mold, you also need to talk very carefully with your designers to make sure that a family mold can happen. Because at times, family molds cannot be produced. Talk to your designer, please, so that the designer can run analysis for you. How are you supposed to produce this family mold? All right. Okay. So when you talk about this, still there is no difference. It has runner weights and it has part weights. But in this particular scenario, the part weight will be different. See, because this guy is brother number 1 and brother number 2. So brother number 1 and brother number 2 is going to have one weight, say 10 grams, right? And you notice that there's a sister here, right? This sister may weigh 15 grams, right? Because he's a different size, he has a different body, right? So now add on together all your parts, you're gonna have brothers that is 10 and 10 each. Let me just write it down so that you can understand it more clearly how that it goes. This is 10 gram, and this is another 10 gram. And this guy is actually 15 gram. The sister is actually 15 gram. So how much is your part weight? Is 10 gram, 10 gram, and 15 grams. So altogether is 35 grams. And if let's say your runner weight is 5 gram, then the total shot weight, we call it the total shot weight, is going to be 10, 35, 40 grams altogether. Meaning to say in any types of production of one single shot means I close my mold and I open them, the machine will draw 40 grams of material from it and produce this thing, right? What comes into the machine, what comes out, right? It's very, very fair, okay? In injection molding is very fair. What goes in and what goes out is the same, okay? So you'll get like 40 grams, okay? So now your parts will be weighed differently and will be calculated differently. So the brothers have different pricing and the sister have different pricing. And some companies, they said, well, I don't really care because I want to buy it in a set. Then you can actually get a set kind of price, right? So that's done, okay? I hope that clears off. If let's say you're clear, type me 3, tell me that you're very clear and I can actually move on to my next steps, all right? So let me see. Are you guys still around? Okay, good. Right, recycle. So Suhaimi is asking whether if this is a recycled material. So they are regrinds. These you mean this? This is actually the runners that was collected. So do we recycle them? Yes, in this case, we only put in 10% of this into the main material if the customer allows. There are certain projects that we are running, we're not allowed to have the regrinds, and typically the customer will have to buy the regrinds, meaning to say the entire runner weight is being discarded. So in this case, sometimes we will work with them on a sustainability program where all these regrinds, we actually help them to produce some other things. So they can actually request that, oh, these regrinds, can we use it to produce something since I cannot put it into my products? So we will be happily developing some other products with them so that they can use it for something else in their factory. And we're very happy to design that. Like, that's our core value. All right. So, okay, coming on next will be the third one. Notice this. It doesn't have any forms of runner as well. Okay, this is called the hot runner mold. So hot runner mold typically is a very pretty mold where it has an additional hot runner systems that actually runs through it and help them to produce the parts. And when that happens, you get 8 cavities of mold. Like this case, you have like 1, 2, 3, 4, 5, 7, 8, and there's no runner. So the benefits of it is you don't need to regrind them. You don't need to pull out the runner. You don't need to have to degate it. Degate it means we have to cut the runner away from this particular place. So what happens is you don't have to do this. And the con sides, like mean the disadvantage about hot runner mold is it requires a little bit of maintenance from the people that is running this. Secondly, a little bit disadvantages would be you will need more costs to produce this mold because each and every one is a hot runner. So you probably spend additional few $100s in terms of US or a few thousand in terms of Malaysian ringgit to just have like additional systems of this. So it will add up to be quite a substantial amount because every single hot runner dot or gate, this is 1 gate, 2 gate, 3 gate, 4 gate, 5, 6. So altogether there will be like 8 gates. So altogether this 8 gates is going to cost you like a whooping maybe additional $5,000 or $6,000 just for the system. And if it's in RM, it's probably another additional top up of like 20 to 30K. So that is a pinch to the customer. However, if once it's run smoothly, so just like Lego runs with like full hot runner because they don't even want to talk about like runners because runners will require them to like regrind it and then you produce slightly lesser, better qualities. All right, slightly. Okay, it very much depends on the needs of the customer. Okay, so that move on to the first very top part. So in our plastic injection part cost, this is the main component. Okay, the material cost takes up approximately 40 to 50% of your entire price. Okay, so we definitely want you to know that it takes up quite a lot of the cost, and this is where you want to be more, you want to talk to your suppliers or your customers, suppliers about how you want to conserve or better run the materials. Okay, so yep, that's where we get the secret number 1, which is the material cost. Okay, moving on next, of course, when you produce something, you need electricity, you need power, you need manpower, right? So the next cost that we're going to discuss about will be the operating cost. So the operating cost would be the machine cost plus the operator cost. Okay, the machine cost basically comes from just now when I said cycle time. Cycle time means how much does it take to produce one piece or one shot. So typically cycle time range from like 20 seconds if you're doing normal injection molding. If you're using fast injection molding, sometimes it can go as low as 8 seconds. Packaging, the food packaging where you take takeaways, the packagings, those type of packagings can typically range from 8 seconds because they were fast injection molding. So this one can go up to like 80 seconds depending on what part are you talking about, right? So it has different cycle time. So that actually involves, that varies a lot in terms of the cost. Imagine a 20-second and 80 seconds. I could very well make like 4 of this in the 80 seconds already, right? So that's why there is a difference, right? Anytime you guys have any questions, just shoot it in the comment. I'll keep checking the comments. All right, cavities, like just now, if it's a 1 cavity, a 2 cavity, a 34 cavity, a 64 cavities, all gives different result in terms of the operating cost. Okay, sometimes someone may ask me this question. I'm not sure whether it's appropriate for me to just say it out loud here because it's going to stream on YouTube and also in Facebook Live. Anyway, some people ask us, how come some country manage to produce very, very cheap products? I can tell you that very likely when they develop a product, they have actually made like 128 cavities of a product. Okay, so if you think about the operation cost, if I close a mold and open a mold, there's 128 wall plugs coming out versus I have a mold that is just now is 24 cavities. Who could sell cheaper? Who could sell cheaper? The A or the B? Come. Shoot in the comments. Who could actually sell cheaper? Is it the A or the B? Yeah, the answer is, of course, it's A. Yeah? The reason why is because at a single point of time, he produced 128 pieces of wall plugs compared to 24 pieces of wall plugs. Okay, that cost is alone is very different already, right? So that is the difference. And then it also varies by the machine tarnish, electricity cost, numbers of operator required depending on how much operators is there. And then after that, the automation. If there is a robotic arm, do you need an operator there? So there is a lot of difference in terms of that. Okay, so I hope you understand that, but stay to the end because at the end of the day, I'm going to share you the homework and the homework of that particular, not homework, basically a bonus where you can actually practice how you want to decide or know more in depth about the calculation of the costing. Okay, so next, the third cost that is going to vary would be the administrative cost, maintenance cost, packaging cost, and the delivery cost. Okay, so imagine that today you're going to deliver this to US. Definitely, you have a very huge delivery cost, right? Compared to you just going to send it out to your neighbor. So packaging cost as well, because sometimes some of the products that we produce require a very sophisticated packaging. You want it to be anti-scratch, you want it to be bumping on the packaging, you want it to be packed in a way that is safe for delivery. Yeah, that actually adds up to a product cost, right? So let's do some homework and let's do some revision. A cost of a plastic parts actually involves, number 1, the material cost. Number 2, the operation cost, which is where your electricity of running the machines, the man hours, well, the salary of the operators, and also some maintenance of the machines goes to the operating cost. And the third part would be the other cost. The other cost comes in with like administration cost. Of course, on the fourth elements would be the profits, okay? Definitely every business would definitely have their profits, so they will add in the profits if they want to. Okay, so this is one secret expose. And the next portion, I'm going to give you some homework, which I'm going to share out the templates as well. Okay, so download this template at this place. Go to bit.ly/costsaving2022 to download this. I am going to shoot this inside the chat box, and we're going to spend some time downloading this. You will have to go to, where is it? You will have to go to this link. Wait, let me just put this into you guys so you guys can. It's bit.ly/costsaving20. There you go. So what happens is you can download this after you insert your company name, your name, and that, so that you could actually own this template. And I'm going to give you a debrief how are you going to use this template to help you with calculating the cost. Okay, so let me just go ahead with sharing the template that you're about to download. I'm going to just give you some time to download it so that maybe you want to do it together with me. Okay. We're going to share. Yeah. All right. Let me just do a share screen. Anyone can't go into the link? Just let me know. Wait. Anyone can't go into the link? I hope that you guys can access it. I'm having trouble finding things. Hang on. Now I'm having trouble finding the things. Oh. Oh. So. Okay. All right, so I hope that you guys already got the template. Yep, okay, my template is up, right. Okay, in this template, I specially created it in a way that you could actually fill it up and then get the answer yourself. So you could actually ask your supplier, your manufacturer, or your OEM manufacturer what are the details if they want to review to you, which for us, we usually will. And then you can actually put this in. So the currencies here, I put it in dollars. Well, if you want, you can put it in your own currencies. Okay, so let me just go through this together with you guys. Right, so just now I mentioned to you that in a plastic injection cost, there are the material cost, the processing cost, the other costs, and also the profits. Okay, feel free to change anything on this column and also in this column as well for additional processing if you have it. If you don't have it, just leave it blank. So there's only two places that you're gonna fill up, here and here. Okay, and we're gonna start. All right, so if let's say you call somebody and tell them that, hey, I am having a mold and we want to check out what is the cost. Let me just start with the part weight. How much is the part weight? So if let's say your part weight is 5 grams, you want to put it in a scale of kg. So 5 divided by 1,000, you get 0.005. And typically you will ask, so what is the runner weight? The runner weight would, let's say, is 10 grams, then it will be 0.01, right? Then altogether, then you will ask them, what is the cavities? The cavities would be 4, 6, 24, or even 1, okay? Sometimes we have like only 1 cavities for low run molds. And you will ask them, what's the material price? So if it's typically an ABS right now is, how much is $2.50, $3? Now it's like $3 to $3.50. If it's in ringgit Malaysia, it's probably going to range around like 10, 12, depending on monthly fluctuations. And typically, a manufacturer put in some losses because there are rejects, which you don't purchase them because you only purchase the parts. So typically, the factories will put in losses around 3%. And these made up the material costs. Okay, if you notice it, a weight that is around 5 grams or 15 grams, your material cost is around like 4 cents. Okay, it's around like 4 cents. So moving up next, you will ask them, what is the cycle time? So, or your customer will provide you, or your supplier will ask you, what is the cycle time? So the manufacturers will demand for cycle time, the cavities, of course, they're not going to tell you what is their operating cost, okay? Typically they won't, but in some cases they do as well. In our industry, you could actually ask them what is the operator cost in that particular country. I actually did Google, like in US, it was like $16 per hour. In Malaysia, we pay much lesser. So probably it's a good time for you to think about like whether you want to come over to Malaysia to inject plastics, okay? It's typically running way less than like $16, like $16. We range quite low in the region. Yeah, so you can actually put in what is the price. So if let's say you're doing this in dollars, use a dollar. If it's you're doing this in RM, please use the RM concept. You don't even have to convert it. I, however, do give out some dollars indication. If you're running smaller molds, they have a production cost that is lesser. If you're running higher molds, you have a production cost that is much higher, right? So you could take this as a guideline. Again, this particular guideline that I'm pointing out here very much depends on the country, currencies, the GDPs, the technicality of the companies, and well, the precisions of the know-how of that particular molder of the manufacturer. So you can be paying a little bit more for those people who has experience doing precision molding. Like us, we probably do have a higher rate for doing precision moldings, which you require more quality control and you require more quality equipments to be being measured for the parts. So that take up some of the costs as well. So very much depends on the locality of that particular molder, and also typically the electricity charge in that particular country, because every single country have a different electricity charge. And also typically you want to look into what is their performance and what is their accuracy in terms of producing. So it's definitely going to be very different if you are producing a part that is in a local depot where you do like flower pots. You don't really need to measure as how precise it is comparatively to doing like here, we're doing like water meters. You definitely need to have a precision so that the water doesn't leak. And as per to even higher ends of like producing medical grades products, you will have different production costs. So this, you probably need to have a heart feel and like gauge a couple of more molders for you to tell that, right? However, this is just a range of a typical normal range of how much it would be. I'm giving you a feeling of how much it would be, and that you can actually gauge it as well, right? So anyone have any questions so far, please shoot it in the comments. Please shoot it in the comments so that I can actually attend to you and answer some of the questions that you have. Moving on next would be the per hour production. So this already calculated, so don't change the formulation. So you just have to plug it in. Okay, maybe I should like just let you guys know. This one you don't have to do anything about it because there's formulas behind it. So anything that you see in this place that has a formulation, do not touch. If not, then your template will go haywire. All right. So, yep. I have to repeat another time. Those that you see there is a formulation, please do not touch. Formulation means there is like an equal there, right? So don't touch it. Okay, so all you need to do is to fill up. So for the processing cost, they will ask you like, what is the cycle time like for this mold? And they'll tell you, okay, typically my molders runs around like 35 seconds, or you probably tell us and say, okay, this mold is like after simulation through some simulation software, it runs around 40 seconds. Okay, so it's like 40 seconds. So plug it in the 40 seconds and put in as cavities, same like this one. What is the cavities? If it's 4, then put in a 4. If it's a 64, put in a 64. If it's 1, put in a 1. And then the operation cost, you can actually refer here. Oh, sorry, the operator cost, you could actually survey, depends on the country, per hour. And then after that, put in the production costs. The production cost will be something that I'm putting in here based on the machine tarnish, bigger or smaller of the machines, and also the variances that I talk about. Okay, so let me do some, before I move on further to other costs, I would like to show you the magic of cavities. Okay, just now remember that I raised a question about why certain countries produces products that were so cheap. Very likely, if let's say I were to think about the whole economic sense to it, it's because that they produce mass production. Okay, so for example, this cavities, if I were to just look at this, I'm going to play a magic here. It's not a magic, but just look at this. If let's say today I am going to have a part that is going to run for 4 cavities. Oh, so that won't change that much. That won't change that much. The changing part will be here, sorry. The changing part with that processing cost. If today this mold is 64 cavities, this is the old price, right? This is the 4 cavity price, which is around 15 cents. If I were to change to 64, can you see how amazing the cost per piece change? From 15 cents down to less than a cent. Of course, sometimes the cycle time will range higher, probably double the time, 60. Still, it's going to be close to only 1 cent. Look at what is the total production pieces produced in an hour. It's 3,840 pieces an hour. If I were to change back this to 4 and this back to 35, look how it changed. It only produced 411 in an hour. Can you understand now why mass production is very important in terms of product designs? And so if let's say you're running for a mass production, you always get back a lot more profits because as a company who produce product, like you guys, you have products, right? If you produce a bigger molds with more cavities, even though the investment to the molds is high, however, the production cost is going to be very low, right? So ideally, after the mass pro phase, you will want to scale up your mold size, but not every project gets to go to that phase. A lot of projects were stuck in the R&D. So sometimes we'll recommend you guys to do a soft tooling where you test out like 100 to 200 pieces of that, and probably you want to test out the market before you want to move forward. So do talk to us if let's say you require some of our services to do this. We'll be very happy to help you out. All right. So moving on to the other one would be the other cost. Other costs will be admin cost, 3%. Additional cost would be 0.032. So I calculate like how much is the hour rate of the operators. So the operator's hour rate is only 16 and it requires 2 processes. If this processes is producing 1,000 and 1,000 each, the additional processing cost is 0.032. Some people ask, what is all this processing cost? Okay, sometimes you will require them to pack. Sometimes you require them to like fix like a screw onto it, and which an OEMer or a molder could help you. Sometimes you want them to like assemble it. You know, remember the brother and the sisters? You can actually ask them to assemble it for you. Of course, those comes with the cost. At times, it depends on how the molder wanted to charge. Some molders don't charge, some molders does. It very much depends on how they simplify and improvise their process. All right, so moving on next, that will be the packaging cost, and here it will be like the transportation cost. So there are some examples that I put in here where you can digest yourself. So it actually adds up to like 25 cents. So if let's say I were to look at this, it's so crazy that the other cost is costing more than my material and also my processing cost. You will want to look into like trying to adjust this so that it becomes lower. You can also talk to the molders and say, hey, can we use, like us, we produce to our nearby, like within our region, we actually give them returnable cartons, meaning to say they put on the cartons and they return the cartons to us and there is no charge in terms of packaging. And there's another way is we can actually put it into like our recycled material bags, and that's also, you know, for free because we got them for free, right? So basically, we would love to discuss that with you. If let's say you are also a very sustainable person, does not want to use so much of carton, we have like a lot of fancy ideas that we can actually help you to ship out your things to your port. Okay, as long as you can clear the customs. Right. Okay. So jokes aside, add up the profit, 10%, 5% is very typical. Typically, most of the manufacturing makes around 5 to 7% in terms of profits here, or some, if you are generous enough to give the molder more, you can actually put them at 10% so that they can use this profit to do more automation for you, and you can demand for a cost down. So very much depends on how you want to invest. Okay, you can actually invest your molder so that your molders can have sufficient money to actually produce more automations or even better quality products or quality gates for you, or even conserve or repair and maintain your mold for you for maybe FOC. Right. So the total of this cost would be like around 50 cents. So literally plastic parts is not going to be very expensive if you have put in enough investment into the mold. Right. So any questions? Okay, just let me check whether any one of you have any questions. No. Right. Okay. And I hope that you guys are still around. And if let's say there's no more question, okay, there is questions like Yusri is asking, those 3% of losses includes potential rejects of parts by client? No. So the potential rejects parts by client is absorbed by the customer. Sorry, it's absorbed by the molder because those rejects that goes to the clients, it's considered a rejects already, and most of the time the molders will replace. If not, then they will work out some method to compensate it in a way. So it very much depends on the negotiations with your molder, and yeah, that's the essence of it. So the 3% is our internal losses here. So we put in around 3% because don't forget, when we start up a mold, if it's on the low run, we still use some materials to purge, which I never put it in here because it's going to complex a lot of things. Okay, so I didn't put in here, there's like purging materials that was put in, right? So yeah, and let me see if there is any more questions. Okay, so basically that's all that I would like to share about how you're going to calculate the cost of this particular production of plastic injection molding. And we want to welcome you. If let's say you need any help from us, you can always shoot us an email. This entire recordings will be recorded. We are going to put it up onto our YouTube channels and also our Facebook Live so that you can replay this and also continue to download the template for your own use. If you need any questions or you have any questions, do drop us an email or what messengers. We have our sales consultant to reply you ASAP. All right. So I really do hope that you guys enjoy this session. I'm very happy that you guys are around and you guys are giving positive feedbacks to me. Because it has been like quite some time since I gone live. So it's good to be back in the new year. Do tell us what sort of information you would like to know about a molder, about injection molding, or even mold making. Do let us know. We'll be very happy to create a live again with you guys so that you guys can benefit more, learn more about what you are dealing with. After all, it's just a win-win situation between you and us, and we really hope that we can create products that can help you benefit your customers as well. So very happy to see you guys here, and I hope to see you soon. Bye.